Okay, these are some practice electrophilic addition mechanism questions for a higher level. Illustrate the mechanism for the reaction between bromine and butanene. So butanene, we've got the double bond on between the first and second carbons, and then we're going to have two more there, 3 H's, 2 H's. So let's figure out how we can maybe do this more condensed. Let's do C2H5 for our butanene. Or you can draw it all out, it's up to you. Okay, and then we're going to have the bromine. And we need to show that the curly arrow, so in the electrophilic addition, the pi bond in the alkene is what's acting almost like a nucleophile. And so the bromine acts as the electrophile, the thing that's going to receive the electron pair. So we need to show a curly arrow going after one of the bromine atoms, and the other curly arrow showing that bond undergoing heterolytic fission. That's our first step, and that's going to leave a carbocation. Now, where do we attach this first bromine atom? We should be thinking about always where would it more likely to be added, and where would the positive charge more likely be in this carbocation. So the concept that will come up again later in these other questions is that the more central the carbocation, the positive charge, can be, the more stable it will be. There's more atoms surrounding it, which can stabilize its positive charge. So when we draw the carbocation, and I have to choose between putting the positive charge on that second carbon or that first carbon, I'm going to choose the second carbon because it's surrounded by more atoms, which will stabilize the charge. So when I draw this, here's the first carbon, and I'm going to say that the bromine has attached there, and now I've got a positive charge here on this second carbon. It also still has that H, and it has the C2H5. So this is the carbocation intermediate. This is the major carbocation intermediate. I also have the Br minus, which was produced by the first step. So the electrons went to that bromine, and so now there's an extra pair of electrons on the bromine. That's why it has a negative charge. So the second step of the mechanism is that this pair will now have a curly arrow showing it forming a bond to that carbocation, and so then the final product will have both bromines across what used to be a double bond, but now there's one bromine on the second carbon and one on the first carbon. So that's how we can show the mechanism for bromination. Now determine the two structural formulas, two possible products with hydrogen chloride and propene. So propene is, you've got the double bond here between the first and second carbon, and then there's a third carbon there. The H and the Cl can either add H on 1 and Cl on 2, or they can add Cl on 1 and they can add H on 2. For the same reason that I outlined above, the major product is the one where the chlorine adds to the second carbon, the one that's more central, because that followed a pathway where we formed a more stable carbocation. So those are the two products. I'm supposed to draw the formulas if I'm following through on my own questions here. And so I'd either get a CH3 connected to a CHCl connected to a CH3, or the other way around is a CH2Cl connected to a CH2 connected to a CH3. The first one here is called 2-chloropropane, and the second one is called 1-chloropropane. Okay, now which product is the major product? Is that first one, the 2-chloropropane, is the major product, and that's because the secondary carbocation, okay, that's the kind of carbocation that I formed up here, the one where this carbon is attached to two other carbons. So the secondary carbocation is more stable than the primary carbocation. Probably should write out secondary just to be careful. So the secondary one is more stable. Why is it more stable? there's a greater, if we want to get really fancy, we say there's a greater positive inductive effect from 2 carbon atoms versus 1 carbon atom. And I'm referring to the neighboring atoms around the positive charge. So this one up here, this carbon has a carbon here and a carbon there that are both helping to stabilize the positive charge. If we put the positive charge on the first carbon, there's only 1 neighboring carbon to help stabilize the charge. So now write out the mechanism, very similar to the one we did at first. I've got the double bond here, which I show go after the HCl. It's going to go after the H versus the Cl because the polarity of this bond means that the H is slightly positive. That's why the H gets attacked by the pi electrons, and the bond breaks heterolytically, so those electrons go to the chlorine. We're going to leave the major carbocation, so the secondary carbocation. That means at this point the hydrogen added to the first carbon, the second carbon is positive, and the chlorine now has picked up this extra electron pair, so it's negative. And so the second step is going to be that the pair from the chlorine attach, and I end up making the secondary 2-chloropropane. So CHCl, CH3. I'm not drawing out structures for the sake of time, but probably you would draw out full structural formulas. This last one is kind of a twist. It asks you to show the reaction with BrCl, which is not one of our normal addition reactions, but you can, if they throw this curveball at you, you have to kind of think through how would this add. Again, if we go back to that butene, so the double bond is between the first couple of carbons, and then we have the C2H5 that continues on. The more stable carbocation is going to be when this carbon becomes positively charged. But now we have to think about, if I have Br and Cl, where's the polarity in this bond? Where is the pi bond going to attack? And between bromine and chlorine, chlorine is the more electronegative atom, and therefore this bond is polar towards the chlorine. The negative end is on the chlorine. And so working backwards from that, that means that when this thing attacks, it's going to attack the one that's a little bit positive. The electrons will go after what's a little bit positive. And so that means the bromine will attach to the first carbon. The carbon in the middle will end up being the carbocation. And the chlorine will end up as this one. And so that then attacks the second carbon. And so in the end, we'll have bromine on the first, and we should have chlorine on the second as the major product of this reaction. So it'd be 1 bromo, 2 chloro, butane. So a bit of a curveball, but if you follow your rules of polarity and the mechanism, you can end up getting to the right major product. Yep, come on, we can stop it.